So for the integrated factor, we need the dy dx plus pxy equals q of x form. We have these two formulas. And what's p of x equal to in my problem? X over x minus 1. That's very unfortunate. What's q of x equal to? E to the negative x. Good. So I of x is going to be e to the integral of p of x over x minus 1 dx. Nice. I'm going to help you with this part. So turn the knob means you take x over x minus 1, turn the knob, the x falls in, leaving x minus 1 out here. X times what is x? 1. So that's going to be 1 x minus 1. And then you're going to subtract. This will be 1. And won't that just be the remainder plus 1 over x minus 1? This is the same as e to the integral of 1 plus 1 over x minus 1. Now, you integrate this as far down as you can. Tell me how you integrated 1. What's that? X, yep. Plus, what's the integral of 1 over x minus 1? And Blake, do you want to help? Yes, natural log of x minus 1. Because u is x minus 1, the derivative is 1, so it's just ln du over u natural log. This is the same as e to the x times e to the log base e of x minus 1. It looks very horrible, but what is it simplified? E to the x times what? This is just x minus 1. That's my I of x. And this is a case where the I of x step is much uglier than the rest. The rest of it's going to be okay. Because now we have the derivative of y iota x minus 1 e to the x is equal to x minus 1 times e to the x. And what was q of x? E to the negative x, or just e to the x in the denominator. Why is that such a good thing? Because those cancel out. And so now when we get d dx, y x minus 1 times e to the x equal to x minus 1, integrate both sides. You're going to get y times x minus 1 e to the x equals what? What will that be equal to? X squared over 2 minus x plus c. Go ahead and find c. They gave us clues here. Y is 1 when x is 0. So when x is 0, y is 1. See if you can use this to find c. So for c, you're going to put y is 1, and then x is going to be 0 minus 1. There's where the negative comes from. E to the 0 equals 0 squared over 2 minus 0 plus c. So this is going to be 0 minus 1 is negative 1 times 1 is equal to c. So we can just change this into a negative 1. Are we done? Liz, I wish we were done, but we still have to solve for y. So see if you can do that at this time. So what I would do is I would say x minus 1 e to the x is equal to x squared over 2 minus 2x over 2 minus 2 over 2. See why I did that? Just so I get a denominator of 2. So y is x squared minus 2x minus 2 over 2 times x minus 1 e to the x. That is the answer. We have fish. How many of you are fisher people? Do a lot of fishing? You do some fishing? What do you like to catch? Walleye, of course. And do you catch a lot throughout the year? What's the biggest one you've caught?
32-inch walleye.
32 inch. You know what the weight?
Fish in general?
No, the. Oh, nice. But I mean, what do you think the weight was of your walleye?
Like
32 inch. That's got to be a 3-pounder, 4-pounder.
That's like 10. That's a really big one.
I don't know if it's. I think so.
If it was like regular girth, that'd be like 10.
So he thinks his was 10 pounds?
It's 32
Sure, we'll
inch
go with that.
walleye,
We'll
yeah.
go with
Okay,
that.
take your calculators, take 10 pounds divided by 2.2, 2.2, and what do you get? That's how many kilograms? 4 point what? So his largest walleye was about a 4 point, did you say 4.2? 5, okay? We're going to look in this one, we're going to take fish. It's normally distributed, so we're going to use our calculators for this. The mean is 1.3 kilograms, and the standard deviation is going to be 0.2 kilograms. Derek's fish was about 3 times this. Okay, so we're talking about pretty average sized fish. This might be even panfish. Do you think? Would a sunfish or bluegill be over 2 pounds? No, probably a bass. Yeah. Determine the probability that a fish is caught weighs 1.4. So here's my big suggestion. Would you draw a bell-shaped curve and then identify the mean is 1.3 kilograms, and what's the standard deviation? 0.2. So wherever you think the inflection point is, I think it's about here, that's going to be 0.2 this way, 0.2 this way. I'm talking, probably 1.5, and this is about 1.1 kilograms here and here. So where they're saying this determine probability that the fish caught weighs less than 1.4. 1.3 is the mean, 1.5 is one standard deviation. I'm looking at that area. And what do you think that area is going to be? Just take a guess. Just throw me a number. Huh? 0.65, sure. 0.7 maybe, but it's for sure more than 0.5, right? So I'd guess it'd be around that. Well, we're going to take our calculators, normal, CDF, and we're going to put in low, high, mean, and standard deviation. Okay, so this is normal, CDF, because we're accumulating the area. Don't do PDF. It'll just get you a Y value, and Y values mean nothing. So the low is, well, we could say 0, but just to be safe, I'm going to put negative 100 for that. 0 will work for this. The high is going to be it's less than 1.4. The mean is 1.3, and the standard deviation is 0.2. I'm going to need your help. What is that probability? Probability that x is less than 1.4. 0.6 what? Go 2 more decimals. 1.5. You got it. That's right. Okay. That one seems fine. So this is normally distributed, but look at what's happening next. John catches 6 fish. N equals 6. Calculate the probability that at least 4 of the fish, so we're going to look at the probability that x is greater than or equal to 4 that are more than 1.4 kilograms. If this is the probability that x is less than 1.4, what do you think the probability that x is more than 1.4? You got it. 1 minus 0.6915, so this is going to be 0.3085. That's the probability. So we know what n is. We know that p is 0.3085, and we're looking at, I have to do this. I know I don't like to do it, but probability of 0, probability of 1, 2, 3, 4, 5, 6 equals 1, right? Because they all add up to 1. And what we want to see is the probability of at least 4. So what are we talking about, at least 4? What are we talking? 4, 5, and 6. Now, you can do that. By the way, which distribution is this going to be? You got a specific n, a specific probability. It fails or it passes. This is binomial, yep. Yep. Okay, so what I'm going to do is I'm going to solve for these by taking 1 minus binomial CDF, because I'm going to accumulate 0, 1, 2. What's the last one I'm going to take away to leave probability 4, 5, and 6? 3. So x here is equal to 3. So you go, I'm just going to write the numbers here. N is 6, P is 0.3085, and X is 3. And I'll write you a little note here. This is N, this is P, and this is my X. Are we clear on the greater than or equal to 4 thing? How to do at least? Does it or does it not help to write these out? Helps. Do it. If it helps, do it. I need your calculator help then. What is 1 minus binomial CDF 6 comma 0.3085 comma 3? What's that equal to? 077 what? 42. I like 4 significant digits. I think they go with 3. And that, by the way, is perfect. That's the right answer. And then the last part, determine the probability that a fish that's caught weighs less than 1 kilogram, given that it's less than 1.4. Let me show you what they're talking about here. Here's kilograms. Here are the kilograms. And here's 1. And here is, here's 1.4. Can you kind of see what's the intersection? Less than 1.4 or less than 1? This is the intersection, isn't it? So what we've got here is a conditional probability that we're looking for x less than or equal to 1, knowing x is less than or equal to what? 1.4. So this is going to be the probability that x is less than or equal to 1. That's the intersection over the total. Probability x is less than 1.4. And that'll be total. Is that all right? I think that one's kind of cool, but a little annoying. We're going to use normal CDF. And we're going to go low as -100 up to 1. And then it was 1.3 comma 0.2 over normal CDF, -100 up to 1.4 this time. 1.3 is the mean, 0.2 is the standard deviation, and I need your help there. What do your calculators say? .0966. That's about, almost 10%. Okay, let's check out the answers there. I've got, I think it's on day 3. I have the answers for those, but I think that's right. I'm pretty sure that's correct. 0.0966, 0.0774, and what was that first one that we got? 0.6915. And those are two problems to kind of show you what the long problems are going to be like. Okay, the shorter ones we're going to get some experience on next. You're going to do number 6, 4, and there's a group one, the math induction problem.